So in this video, we're going to go over problems 74, 75, 76, and 78, and then 80 and 81 will be your homework. This is on chords and angles. I also set this up ahead of time. So we did skip this section, section 10.2.1, I think. A chord is a line segment that connects endpoints of an arc. That's the first definition your book gives, but it's also the same thing, the line segment with endpoints on the circle. So this right here is a chord because the endpoints are on the circle. If it goes through the center, it's still a chord. It's just a special chord that we know as a diameter. So arc, those are the endpoints, and that's what we call a chord. A chord is a line segment, so it's straight. So problem 74, here's parts kind of, I think, A, B, and C all tied together. So it tells us that QR is 180 degrees. So we have a semicircle atop the circle, and we want to know what is the measure of angle P. So because this is an arc, we hopefully remember from the last lesson that the inscribed angle has to be half of the arc measure. So angle P has to be 90 degrees. So this has to be 90 degrees there. It doesn't really look like it. And then, so QR, if we draw it, not drawn to scale, sorry, QR is a diameter. Again, it cuts the circle in half, and we know that because that's 180 degrees. The picture in your book is much better than that one. And then it says, what if P was in a different location? So if I put P here, that wouldn't change it. We would still have a right triangle there because that's still 180, that angle is 90, still a diameter. So on part D, it wants us to kind of apply this. It says UV is a diameter, and it wants us to find a radius. So if this is a diameter, that tells us it cuts the circle in half. That tells us this is 180 and this is 90. So we have a right triangle. Anytime you have a diameter, you have a right triangle. So let's call this X. 6 squared plus 8 squared equals X squared. So 36 plus 64 is X squared. 100 equals X squared, so X equals 10. So UV is 10, which then tells us our radius is 5 because UV is the diameter. Problem 75, I kind of broke it up looking ahead. So it looks like this. Angle BCD is 100 degrees, angle BAD is X, and that's what we're trying to find. So there's kind of a lot going on in this picture here. So I was trying to break it down. So if I just draw this and kind of erase those lines, angle BCD is 100 degrees, same thing. So that tells us that this arc here, BAD, this guy, would be 200 degrees. Right? So you double the inscribed angle to get the arc. Okay. So from here to here to here is 200. That tells us that this leftover piece, BCD, has to be 160. The reason it's 160 is because these have to add up to 360 because it's all the way around the circle. So here, this arc BD is 160. So this angle X, that inscribed angle, has to be 80 degrees. So 100, and that's 80. So notice 100 plus 80 is 180. So those are going to be supplementary. So this, you could follow the same pattern, but opposite angles of a quadrilateral inscribed in a circle are always supplementary. That's kind of a lot of words right there. So a quadrilateral, 4 sides. So if each vertex is on the circle, these opposite angles are going to add up to 180. So angles B and D, I don't know what they are, but I know together they're 180. And then problem 76 says, what if 2 chords intersect inside a circle? So we have 2 chords, neither of them go through the center. And what if they intersect? So on this problem, it says that Timothy decided to create 2 triangles, and they have letters, but I don't think it's important. So if I make those 2 triangles, these are similar triangles. By angle-angle similarity. The reason they have angle-angle similarity, they have the vertical angles, and then like this angle here and this angle here. So if I kind of think of those lines, they use the same arc. So anytime you have 2 chords intersect inside a circle like that, you can draw 2 triangles, or draw 2 more line segments and draw similar triangles. I could have drawn the line segments this way. It would do the same thing. So if I have these similar triangles, we know similar triangles are proportional. That's why this is really helpful. So the book says this is 8, this is 6. Remember, those angles were the same and those angles were the same. What else does it tell us? This is 4. And we want to find this guy, X. So, similar triangles, we just go ahead and set up a proportion. You can set this up several different ways. 8 over 6 equals 4 over X. You could set it up as 8 over 4 equals 6 over X. Either way, it doesn't matter, but you're going to get X equals 3. So it's important when these chords intersect to think of them as similar triangles, because that tells you, again, sides are proportional. Problems aren't going to tell you to set up triangles like that. It's just something you should hopefully recognize moving forward. And then problem 78 just kind of has us applying all of this. So on part A here, it tells us, so we, again, goes right back to where we just let off. We have 2 intersecting chords. It tells us that KL is 8. So if KL is 8, that means that KQ has to be 6, because this whole thing is 8, that much is 2, 6 was missing. So we just go ahead and set up a proportion. Again, the reason we set up a proportion is I can make these 2 triangles. It doesn't matter how you want to set them up. I could set them up this way or the other way. But here, angles P and L would be congruent because they both use endpoints K and M. And then we also have the vertical angles. That just helps you know what sides to match up. So 6 over X equals 3 over 2. Or you can set it up as 6 over 3 equals X over 2. Either way, when you cross multiply, you get 12 equals 3x and x equals 4. Alright, part B is a little bit trickier. They don't give you any numbers. And, I think they were asking us to find angle R. So, it tells us RT is a diameter. So, RT is a diameter. That tells us that this RT, this arc is 180, which tells us angle S is 90 degrees. So we know we have a right triangle. We also, if you kind of look at these tick marks, RS is equal to R to the center, which is equal to the center to T. So the hypotenuse is twice as long as this leg. So if I kind of think about it like this, ignore that that's, so this is, if this is Y, this is 2Y. You double it. That right there, we could do Pythagorean theorem and find the missing side if we wanted to. In terms of Y, we wouldn't have just a number. But that should let us know that we have a 30, 60, 90 triangle when the hypotenuse is double the leg. So X here is 60 degrees because that's the large angle across from the long side. And finally, down here on part C, we're finding this X here. They give us this arc measure is 131 from E to G. We know this inscribed angle is 52, so that's going to help us because we can find this arc measure. So remember, you double it, so 52 times 2, this will give us 104. And then we should know all the way around the circle is 360. So 104 plus X plus 131 is equal to 360. You don't necessarily have to set it up as an equation like that, but you can. So 235 plus X is equal to 360. So X is equal to 125 degrees.